We tend to think of aging as this inevitable decline, right? But what if that's not the whole story? What if a lot of what we call getting older is actually driven by this single hidden process, almost like a biological fire just smoldering inside us for decades? That's what we're digging into today, the science that's totally flipping our understanding of aging on its head. Yeah, it's like a whisper. It works completely under the radar, building up damage year after year. So quietly, you just don't notice it. But all that quiet work, it eventually leads to the chronic diseases we just assume are a normal part of aging.
So think about this: fatigue, brain fog, maybe gaining a little weight. Sound familiar? We usually just shrug and say, well, I'm just getting older. But what if they're not just random signs? What if they're actually the first faint smoke signals from that hidden fire, trying to warn us that something much bigger is happening on a cellular level?
Okay, so it's time to put a name to our prime suspect. Scientists have a word for this whole thing, and it's really the heart of our entire investigation. They call it inflammaging. Yep, it's a mashup of inflammation and aging, and it's the key to this whole mystery. So, what is it exactly? Well, the scientific definition is super specific. This isn't the kind of inflammation you get when you cut your finger or get sick. Nope, this is totally different. It's chronic, meaning it's always there. It's sterile, so there's no infection causing it. And it's low grade, just this constant quiet hum of immune activity that kind of becomes a permanent feature of our bodies as we get older. And the metaphor that researchers keep coming back to is just so powerful and honestly spot on: a smoldering fire. It's not a raging inferno, but it never ever goes out. And that constant, low-level heat, it just slowly, quietly damages our cells and tissues decade after decade. And this is where we have to make a really important distinction. See, not all inflammation is bad. Acute inflammation is actually your friend. It's like the body's firefighter. It rushes in to heal a wound or fight off a bug, and then, and this is key, it leaves. But inflammaging, that's the smoldering fire that's left behind. It's this persistent, harmful state that doesn't heal you. It actually leads to degeneration. Okay, so if there's no infection, what in the world is feeding this fire? Well, the investigation shows it's not just one thing. It's more like a collection of internal culprits, just byproducts of life itself that build up over time. Let's unmask them, one by one. All right, culprit number one sounds like it's straight out of a horror movie: zombie cells. Seriously, the scientific name is senescent cells, and they're a major source of the inflammatory signals that keep that smoldering fire going. So how does a perfectly normal cell go full zombie? Well, it starts with some kind of damage. To stop that damage from spreading, the cell does something smart. It hits the brakes and enters senescence, meaning it can never divide again. But here's the catch. As we get older, our immune system isn't as good at cleaning these cells up, so they stick around. And even though they can't divide, they're still active, and they just spew out this nasty cocktail of inflammatory molecules. Scientists call this the CESP. You can think of it as a constant distress signal that screams to all the healthy cells nearby something is wrong, and basically poisons the neighborhood, spreading that inflammation. All right, let's move on to our next culprit, and this one might surprise you. It's your gut. Yeah, those trillions of microbes living inside you, they play a massive role in regulating your body's inflammation levels as you age. Here's the key thing to understand. The mix of bacteria in our gut literally changes as we get older. We start to lose some of the good guys, like Akkermansia, and we get more of the pro-inflammatory types, like proteobacteria. And this shift isn't just happening in the gut. It's directly linked to higher inflammation all over the body. So what happens when that ecosystem gets out of whack? Well, it weakens the barrier of your intestines. Imagine the mortar between bricks starting to crumble. This allows these tiny inflammatory bits of bacteria to actually leak out of the gut and into your bloodstream. And once they're in circulation, they put your entire body's immune system on a constant, low-grade red alert. And that brings us to our final set of culprits, basically the buildup of internal garbage. See, over a lifetime, our cells' internal cleaning crews just get less efficient. Damaged parts like broken down mitochondria start to pile up, and they pump out these damaging molecules called reactive oxygen species. All the cellular debris is like a constant alarm bell, triggering this internal sensor called the inflammasome. Think of it as the cell's emergency alert system. And what does it do? It pumps out even more inflammatory signals, just feeding that vicious cycle.
So, okay, we've got our fire, we've identified the culprits feeding it, but how do we actually know it's happening? Let's open up the evidence file and see how scientists can literally read the smoke signals of inflammaging.
And that's a really important question, right? If this whole thing is silent, is it just a theory? Well, the answer is a hard no. We can absolutely measure it. Yeah, this inflammation process isn't invisible at all. It leaves behind these very distinct molecular fingerprints that we can actually find in your blood. We call them biomarkers, and they give us a direct window into just how much of that smoldering inflammation is going on inside. The really critical thing here is that we can track this stuff. For instance, a doctor can measure something called high-sensitivity C-reactive protein, or HSCRP, to get a snapshot of your body's overall inflammation. Other huge ones are interleukin-6, which is a direct inflammatory signal tied to things like frailty, and homocysteine, which points to stress and damage in your blood vessels. These aren't just random letters and numbers. They are real, quantifiable signs of that fire smoldering inside. Okay, so we've looked at the fire, we've met the culprits, and we've seen the evidence. Now it's time to talk about the consequences. What happens when this smoldering fire is just left to burn, decade after decade? Well, this is where that tiny spark of cellular trouble really ignites into the full-blown flame of disease. And listen, if you take away only one thing from this, let it be this. For the longest time, we thought of inflammation as just a side effect of diseases, like heart disease or diabetes. The new way of thinking, the paradigm shift, is that inflammaging is a fundamental cause. It's like the common soil from which all these different diseases of aging grow. And you can see that devastating connection right here. That constant inflammation damages blood vessels, which leads straight to cardiovascular disease. It fuels inflammation in the brain, a key part of Alzheimer's. It messes with how your body handles sugar, leading to type 2 diabetes. It even creates an environment where cancer is more likely to take hold. And it's what drives the muscle loss and frailty that can rob people of their independence. It is the thread that connects them all. But understanding this link isn't just a grim diagnosis. It's actually opening up a completely new horizon, a whole new way of thinking about health and longevity in the 21st century. And this is a monumental shift, really. Instead of just playing whack-a-mole, treating each disease as it pops up, the science of aging, geroscience, is now asking a much bigger question. Can we target the underlying process of inflammaging itself? Can we actually put out that smoldering fire and maybe prevent a whole bunch of these diseases from ever starting? And we're already starting to see this new approach in action. One of the most exciting frontiers is the development of drugs called senolytics. Remember those zombie cells we talked about? Well, senolytics are designed to be like a precision cleanup crew. They go in, they find, and they eliminate these senescent cells, essentially cutting off a major fuel source for all that inflammation. Which brings us to one last, really provocative thought. If inflammaging is a main driver of how we age and the diseases we get, and if we're starting to develop tools to target it directly, it raises a pretty profound question. Could the number of healthy, vibrant years we get to live, our health span, one day be less about luck and more a matter of choice?